All right, so this is 7.6 Part B, second part. It's the same thing that we were doing yesterday, but just going over in a little bit more depth. Let's quickly review what we did yesterday, or what we did previously in this do now. So I just want to go over this to give you a little bit more support on that. So inverse of sine of negative square root of 2 over 2. So if you recall, that is the same thing as saying we want the sine of theta equal to negative square root of 2 over 2. So what that means is we want to know when the sine of theta is equal to negative square root of 2 over 2. Now recall, the sine, inverse sine, has to be in between negative 2 pi and, negative pi over 2 and positive pi over 2. So we look at this, and you don't have to draw a triangle, but it certainly helps for some people. We know that the opposite side is square root of 2 and the hypotenuse is 2. So therefore this theta, because it's this type of triangle, is going to have to be a 45-degree angle, or pi fourths. Because it's negative, that means it's going to be in the bottom right quadrant. So here theta would have to be equal to negative pi over 4. Okay, next one is cosine of 1/2. Again, I'm just going to look at this triangle now because we already know what we're looking for. That means we're looking for cosine of 1/2. That means that this angle right here is going to be a 60-degree angle. Okay, a 60-degree angle is pi thirds. It's positive, so pi thirds is what we want. Last one, tangent of 1. Tangent of 1 is going to be a 45, 45, 90 triangle because we have square root of 2, square root of 2, and then 2. These tangent is opposite over adjacent. Square root of 2 over square root of 2 is 1. So therefore this angle is going to be a 45-degree angle, which means that has to be pi over 4. Okay, and again, because it's positive, we know which quadrant it's going to be in, which is typically the first quadrant. Okay, so now let's finish up with these ones. We just want to go over a couple of different examples here. We have the tangent of inverse sine of negative 1/2. So again, the idea here is we know how to find this now. So we do the inverse sine of negative 1/2, which is, that means we're looking for the sine of theta equals negative 1/2. Well, negative 1/2, again, if we draw our triangle, is going to be 1 over 2, which means this has to be a 30-degree angle. Because it's negative, it's going to go below in the bottom quadrant there. So that means that theta there is going to equal negative pi over 6. So in a sense, we're just looking for the tangent of pi over 6. Sorry, tangent of negative pi over 6. Okay? Again, that's 30 degrees right there. There's our triangle. That's what negative pi over 6 is. Negative 1 over the square root of 3. So we have negative 1 over the square root of 3. And again, we have to rationalize our denominator always. So that's negative square root of 3 over 3. Okay, we go to the cosine. We talked about this yesterday. An inverse cosine and a regular cosine are just simply going to cancel out, always. If you have the same thing, an inverse and a non-inverse, they will always cancel out. And our answer here is just square root of 3 over 2. On the last one, again, we'll use the top triangle that we have there. So we have cosine of square root of 3 over 2. So let's look at this. So cosine square root of 3 over 2 means we're dealing with a 30-degree angle. So therefore, we're just looking for the sine of 30 degrees, or the sine of pi over 6. Okay? So the sine of pi over 6. Again, how do we get that? Because we're using this triangle to look at, we have cosine is adjacent over hypotenuse, so therefore 30-degree angle is what we use there. So it's 30 degrees is pi over 6. Find the sine of pi over 6, which is negative 1 over 2. So we get negative 1 over 2 is our answer. Okay, so these are the easy ones because we're using our special right triangles or our unit circle to do it. So now let's go down to this one over here. This is a little bit different, but in some ways easier, because really what we're looking at here is we're just creating a triangle that would be all four of these sides. So we already know that this is theta right here. We know the opposite side is 5, and we know the hypotenuse is 13 because of what is given to us, 5 over 13. So now what we do is we can find what the third side is by simply doing the Pythagorean theorem. So we would find that this side is 12. The deal is, though, is what we're getting here is if you are doing the inverse sine of 5 over 13, this right here is just equal to theta. So in a sense, we're just figuring out what now the tangent of theta is. This is just theta. The only reason why we need this is to figure out what the three sides of our right triangle are. So theta is theta. We don't care what theta is. We just want to know what the tangent of theta is. And that will be 5 over 12. Okay, next one, same idea. Let's draw the triangle. Okay, so we have negative 3 over 5. So that means they're saying this is negative 3 and this is 5, because remember the hypotenuse always has to be positive. So what we can do is figure out what our missing side is. So you do 5 squared equals negative 3 squared plus x squared. Solve for x and you'll find out that it's 4. Again, here's our theta. This entire portion right here just becomes theta. So we just want the cosine of theta, which is 4 over 5. Okay? The only thing that you want to pay attention to here is where we're dealing with this. So based on what we have here, this is going to be in the fourth quadrant. So what you want to think about is what is the cosine in the fourth quadrant? It's positive. So that's how we know that this answer is positive. That's how we know that this is a positive 4 and not a negative 4. Because this right here has to be in the fourth quadrant. And in the fourth quadrant, we know cosine is always positive, so the answer stays positive. But again, it's real simple. You're just finding the third side of a triangle, and then you're figuring out your trig function based off of that. So that's all we have. We're going to work on this a little bit more in class. Again, take your Edmodo quiz if that has been assigned, and I will see you in class.